So now we're looking at grade 8 1.2 in the math textbook, which is on prime factorization. Prime factorization is really cool because what it does is it takes any possible whole number and it breaks it down into its smallest building blocks. What do you have to multiply together to get that larger number? So what are the smallest possible numbers? And we know, we learned in the last lesson, that the smallest possible numbers that don't have any other factors smaller than it are what we call prime numbers. They can't be divided up into anything else because, well, there's nothing else that will multiply together to get that number. So what we're going to look at is the prime factorization of a number, which is the breaking down of a whole number into a product of prime numbers. If you don't remember what product was, take a moment to reflect, and it means the multiplication of prime numbers. So here's the first example. We're going to use a factor tree. That's a little visual strategy in order to find out how to break it down, to find the prime factorizations of 24. So what we're going to do is we're going to try to break up 24 into smaller numbers, i.e. what are dimensions that will make the rectangle 24. Now, of course, we don't want to divide by 1 because you'll end up again with 24 and you'll just be repeating that division forever. So let's try other numbers that will go into 24 until we can get a prime number, because then we can't go any further. So we know that 24 is even, so we can just use 2 times 12. So this means 2 times 12. I'm going to actually delete this multiplication sign just so that we can keep it a little bit cleaner, and just know that 24 breaks up into 2 times 12. It's a visual representation. It doesn't really mean very much. It just helps us do the mathematics. Now, if we try to divide 2 further, we can't because 2 is prime. There are no other rectangles except a 1 by 2 rectangle that will make the number 2. So I'm going to circle that number because I can't go any further in that branch. But 12, can I make other smaller rectangles that will make an area of 12? And yeah, sure, I can make a 3 by 4 rectangle. So 3 times 4 is 12. Again, so I look at these two factors that make up the 12, and I see if any of them are prime, or if I can continue dividing them. I see that 3 is prime. I remember from the last lesson that 3 can only make a 3 by 1 rectangle. I'm having some problems with my colors here. Blue. And now I have the number 4. And I remember that 4 is also 2 by 2. And then I can circle those numbers because I know from earlier on that those are also prime. So now that I've reached all my numbers are prime, I can't go any further because I can't divide them up into smaller rectangles anymore. So what we're going to do is I'm going to list them all out. 24 is the product of all of these prime numbers because I took all of the possible numbers and broke them down into smaller ones, which end up being the prime numbers. So let's put them in numerical order to keep it a little bit neater. So I have 2, I have another 2, I have another 2, and I have a 3. So I can just count. I have 1, 2, 3, 4 factors. I have 4 factors that are prime. I can use my calculator or my head to just reconfirm. 2 times 2 is 4, times 2 is 8, times 3 is 24. So that ends up with the prime factorization of 2 times 2 times 2 times 3. Now, if you remember from grade 7, if we see a repeated multiplication of something, we can actually condense that. If we see 2 times 2 times 2, it's a repeated multiplication, and in math, we can represent that as a power. And if you remember, powers mean the larger number is the number being multiplied. The smaller number, or the exponent, tells you how many times together it's being multiplied, and in this case, it's multiplied together 3 times. So I read this 2 to the 3rd power, which means 2 times 2 times 2. So, and that, all on its own, 2 to the 3rd power is 8. And I keep 3 as another prime factor. So this is the official prime factorization, is 2 to the 3rd power, or 2 raised to the 3rd power times 3, or 2 times 2 times 2 times 3. Now, you might be questioning about how I did the factor tree, and you're thinking, well, aren't there other possibilities to make that original rectangle of 24? And yes, there are. So let's try it a different way, just to see if we can get a different answer. Well, if you remember 24, we can also make a rectangle that is 4 by 6. So a rectangle that's 4 by 6 is also possible dimensions of 24. Can I circle, or can I go any further with 4? Can I break that up into smaller prime factors? Sure. Just like before, 4 divides into 2 and 2. I can't go any further with those. And I can divide 6 into a rectangle that's 2 by 3. And I think you're jumping ahead when you realize what the answer is probably going to be. When I circle my prime factors, I notice that the prime factors are exactly the same as my other factor tree. The reason why is that I can use any combination of these prime factors to get then the original number. So I could do the 2 times 2 first, or I could choose the 2 times 3 first, and then I can multiply by the other 2's. So any combination will work as long as I have the same combination of 2, 2, 2, and 3 to get 24. So hopefully you can try out a couple more examples in class, and if you have any questions, you can let me know. I hope you understood the lesson.